Introduction to Stack Data Structure. What is a stack? So let's start by understanding what a stack is. Let's imagine a stack of plates. When you add a new plate, you would place it on top of the others. And when you need a plate, you take the top one off. This is the essence of a stack in data structures. Stack is a linear collection of elements where addition, you would often call it as push as well, and removal, you will call it as pop as well, of items take place at the end. And this end is often referred to as the top of the stack. And the method of operation is known as last in, first out, or in short, you call it a LIFO. Now, and yeah, this is usually the drawing you would see when describing stack. Basic operations. So in the context of a stack, there are four fundamental operations that you would need to be familiar with. First, we have push. In push, where we add an element to the top of the stack, and then next is pop, and pop involves removing the top element from the stack. Then we have peek or top, and peek or top allows us to view the top element without removing it. And finally, there's isEmpty. IsEmpty checks whether the stack is empty or not. And these operations are the core actions you'll perform with any stack implementation. And on the right, this is Python code. It is using Python list as a stack. If we are using Python list as stack, what you would do is you would use append method as a push operation, and pop would just call pop method without passing any parameters. As a default, when you call pop, it would pop the last element in the list. And then the peek top operation would look at the last element in the stack, and is to see whether it's empty or not, we would check the length of stack to see if it's equal to 0. Implementation of stack. So we're going to talk about how we can implement a stack. There are two common approaches. You can use an array, or you can use a linked list. With an array, we have a fixed size stack. What we mean by fixed size stack is that the size is defined at the start and cannot change. And this approach is simple but can be limiting. On the other hand, a linked list provides a dynamic size stack where the stack can grow and shrink as needed. Each approach, I would say, has its advantages and disadvantages, and it depends on the context in which you are using the stack. So you want to know whether you need dynamic size stack or if it's okay to have fixed size stack. So here is a Python example of a fixed size stack on the left and linked list based stack. So the fixed size stack can be limiting. On the other hand, linked list based stack gives dynamic size, which means stack can grow and shrink as needed. Applications of stack. You may be wondering where stacks are used in the real world. Well, stacks have a lot of applications. Stacks are used in managing function calls and returns in programming. They are also used enabling undo mechanisms in software. You can use stack to parse syntax in compilers, and even they're used in algorithms like depth first search. So for those of you curious about these, I highly encourage you to kind of look into each case and see how versatile and essential stacks are. Time complexity. So for stacks, the operations of push, pop, peek, and is empty are typically O1. It means that they operate in constant time. This efficiency is one of the reasons why stacks are so widely used. However, it's good to consider context of your application and how the time complexity of these operations may impact performance. Conclusion: to summarize, we looked at what a stack is and stack's operations. We looked at example Python implementation and applications. So stack is really crucial if you are programming. So mastering stack, so understanding its use cases will significantly benefit you in your career. So I highly encourage you to keep practicing and look more into stack implementations in the standard library and experiment with stacks in different scenarios. Thank you everyone for listening.